Hi, this is Marwa, and today we will be doing our second video about radical equations. In our previous video we have discussed the basics of solving radical equations. Today we will see what we're going to do when we have more advanced questions. We have two questions up ahead of us. The one that says radical 3x plus 7 is equal to x minus 1, and the other one is radical 5 minus x minus radical x equal to 1. We will see how we're going to find the solution for both questions, and we will see what is meant by extraneous solutions. So let's start with our first question. Now in this question here, they say solve and check for extraneous solutions. What do you mean by extraneous solutions? Now sometimes when you solve, you will work algebraically and all your steps will be correct. Then when you get your final answer and you try to check if it works, it doesn't. Now, because of the rules of the domain of radical functions and how it's graphed, which we are going to discuss later in future videos, not all solutions work. Some solutions do, some solutions you will get algebraically, but when you try to graph them, they won't work for you. So let's see how that happens. Now in the question we have here, we have radical x, radical 3x plus 7, and that's equal to x minus 1. Actually, we are going to do the exact same thing we did in the previous questions we have. What is that? Now we have radical and we want to undo it, so we're gonna, because this is a square root, we are going to square both sides. Now when you square both sides of the equation, you will get a quadratic function. Like when you square the radical will cancel and you will get 3x plus 7. That's not the issue here. But in this case, this is actually x minus 1 multiplied by x minus 1, multiplication of two binomials. So this is going to be x squared minus 2x plus 1. How does that happen, in case you don't remember? Well, I have x minus 1 and that's multiplied by another x minus 1. So two binomials. When you multiply using distributive property or FOIL, you will get x times x, which is x squared. Then you will get minus x, another minus x, then plus 1. When you simplify, you'll get x squared minus 2x plus 1. Now you should be able to do this in one step. How? If I am squaring a binomial, it's going to be the first square, so x squared, the last square, so negative 1 square, which is 1. Then you're going to multiply x times negative 1 times 2, because it's going to happen twice. So x times negative 1 is negative x times 2 is negative 2x. Why? Because it happened twice. Negative x plus negative x. Okay? Now that we have this, this looks like a quadratic. The only way you can solve a quadratic equation is by making it equal to 0 and factoring. So for me to do that, I need everything to be on the same side of the equation. And make that on the side where x squared is positive, so you can actually factor it. So this means this side. So I'm going to have x squared minus 2x plus 1. Then minus 3x minus 7. And that's always equal to 0. So you'll get 0 equal to x squared minus, we have 2x and 3x. So that's minus 5x, and that's minus 6. Now when you factor this, we will get, because the sum, the product is negative and the sum is negative also, so both of them has opposite signs, one positive and one negative, and the negative of course is 6 and the positive is 1. So we have x equals negative 1 as a solution and x equals 6 as a solution. Now we got two solutions for this equation. However, when we check, not both of them would work. Let's check how. Now if I check the first solution, I have 3 multiplied by negative 1 plus 7, and I am not sure yet if it's equal to negative 1 minus 1. Well, so this is negative 3 plus 7, which is 4, and I am not sure if it's equal to negative 2. Well, the square root of 4 is 2. Take care, as we said before, we work with the principal roots only, or the positive roots only. We don't use the negative roots. So these are not equal, and this solution, which is x is equal to negative 1, is what we call to be an extraneous solution. Let's check the other one. Well, we have 3 multiplied by 6 plus 7, and we are not sure if it's equal to 6. Minus 1, well, 3 times 6 is 18, plus 7, that's a 25. And in this case, is it equal to 5? Well, the square root of 25 is 5, that's the principal root, and it is equal to 5, and this checks. So the only solution is x equal to 6. X equal to -1 is not a solution. It's an extraneous solution, which works algebraically, but when we check, it doesn't check to be right. If we graph, it will not be a solution on the graph. Let's look at our second question. Now here we have another question which involves two radicals. Like I have the square root of 5 minus x minus square root of x equals to 1. Now we can't actually square it in this situation. It will be very hard to solve. However, if I isolate the radicals, like put each one of them on different sides of the equation, we have a better chance of solving. So all I did is move one of those radicals by adding radical x to both sides, so we only have it on one side of the equation. Next thing I'm going to do, what we do usually, which is square both sides. When we square both sides of the equation, this is going to be 5 minus x. And here, as we said before, the first square, which is radical x times radical x, will give you x. Last square, 1 times 1 will give you 1. Then you're going to multiply radical x by 1 multiplied by 2, which is 2 radical x. Okay? Now, this here does not look like a quadratic to me. However, what I can do is I can isolate this radical, and if I isolate it, I'm going to solve it again by squaring. So here on this side, I'm going to have 5 minus x minus another x minus 1 equals to 2 radical x. So here you have 5 minus 1, which is 4, and that 4 is minus 2x, and that's equal to 2 radical x. Now again, I'm going to square both sides of the equation to get rid of the radical. So if I square both sides of the equation, this is squared and this also is squared. Now this time you have a good chance of getting a quadratic. Now 4 squared is 16, and 4 times -2 is -8, multiplied by 2 is -16x, and that's plus 4x squared, and that's equal to, now when you square this, the square goes to the 2 and to the radical x. So 2 squared is 4, and radical x squared is x. Now I need again everything to be one side of the equation, so I can factor the quadratic. So I have -4x squared, -16x minus 4x, that's going to be a -20x, then plus 16, and that's equal to 0. I can divide the whole equation by 4. I'll get x squared minus 5x plus 4 equal to 0. I'll factor, and you will get x minus 4 and x minus 1 equal to 0. You have two solutions in this case, which is x equal to 4 and x equal to 1, and let's check which one of them is an extraneous solution. So let's, by checking, I have 5 minus 4 minus radical 4, and we are not sure if that's equal to 1. Well, 5 minus 4 is radical 1. Radical 1 minus radical 4, we're not sure if it's equal to 1. 1 minus 2, well, -1 is not equal to 1 again, so this is not a solution. Let's choose the one. We have 5 minus 1 minus radical 1, and we are not sure if it's equal to 1 again. So radical 4 minus radical 1, that's a 2 minus 1, and yes, 1 is equal to 1. So the only solution again is x equals 1. So again, we found two solutions. One of them was extraneous, this one, because it did not work out, so this was an extraneous solution, and the other one actually worked out, which is x plus equal to 1. This is the only solution for this equation. So if I have more than one radical, what do we do? Put them one on a different side of the equation, square both, you will get another radical, isolate it and square it again until you get two solutions for the equations. Now this was our second video about radical equations and how to solve them. The first one had more basic questions, they were easier. This one has a higher level of questions, and in this video we understood what does it mean extraneous solutions. Extraneous solutions is a solution that would work for you algebraically, all your steps are right and you will get it correct and everything, but when you check in the equation it does not work. Why? This is affected by the domain of the radical function, which we will discuss with the graphs in future videos. I hope this has been helpful for you, and thank you so much for watching.